Hello friends, welcome to True Abundant Academy. In the last lecture we have discussed up to question number 6. So we will discuss question number 7 onwards in this particular lecture. Okay, so let's start. So what is given in the question number 7 is that a body is projected at an angle of alpha to the horizontal so as to clear two walls of equal height. Two walls of equal height A at a distance 2a from each other. So that the range is equal to 2a cot alpha by 2. Okay, so let us draw the diagram of this. So we have the body is projected at an angle of alpha to the horizontal. Okay, so this is alpha. Okay, so as to clear two walls of equal distance A at a distance 2a from each other. There are two walls. This is first wall, this is second wall. Heart of the wall is A. And distance between the walls is 2a. Okay. Now let us consider this distance of the first wall from the origin as x1 and distance of wall 2 from origin as x2. Okay, so by symmetry this distance will also be x1. Okay, so range is equal to क्या होगा? Range is equal to x1 plus x2. Okay, by symmetry. Okay, so this is symmetrical. So this distance will be equal. This distance will be equal to this distance by symmetry. Okay, so the coordinate of this one will be x1 comma a, and this one will be x2 comma a. Okay, so let us further solve this. Okay, so we have the equation of trajectory as y is equal to x tan alpha minus gx square upon 2u square cos square alpha. Okay, so if we put y is equal to a here, so we have the coordinates as x1 and x2. Okay, so putting y is equal to a, we have x is equal to x1 and x2. Okay, so let us put y is equal to a. So a is equal to x tan alpha minus gx square upon 2u square cos square alpha. Okay, so we have gx square upon 2u square cos square alpha minus x tan alpha plus a is equal to 0. Okay, so let us further simplify this. So we have x square minus x tan alpha into, let us multiply reverse of this. So this is 2u square cos square alpha upon g. Okay, plus a into 2u square cos square alpha upon g. Okay, is equal to 0. So this is x square. So let us further simplify this. So x square minus x tan alpha, we can write sin alpha upon cos alpha into 2u square cos square alpha upon g into a, plus 2u square cos square alpha upon g into a is equal to 0. Okay, so we have x square minus 2u square upon g sin alpha cos alpha into x plus 2u square cos square alpha upon g into a is equal to 0. Okay, so this is our quadratic equation. Okay, so now we have in this quadratic equation we have roots as x1 and x2. Okay, so we have from the general properties of quadratic equation, let us consider a quadratic equation ax square plus bx plus c is equal to 0. So we have, if the roots are x1 and x2, so we have sum of roots x1 plus x2 is equal to minus b by a, and x1 x2 is equal to c by a. So let us apply this here. Okay, so let us apply this. So we have x1 plus x2 is equal to 2u square upon g sin alpha cos alpha. Okay, so this is equal to x1 plus x2. So this is x1, this is x2. The range is equal to x1 plus x2. So this is equal to range. Okay, from here u square is equal to gr upon 2 sin alpha cos alpha. Okay, so we have x1 minus x2, x2 minus x1. Let us find x2 minus x1. So x2 minus x1 whole square will be x1 plus x2 whole square minus 4 x1 x2. So x2 minus x1. So x2 minus x1 is, this is 2a, equal to 2a. So this is 4a square. So 4a square is equal to x1 plus x2 is this r square minus 4 x1 x2. x1 x2 is equal to c by a. Okay, so this is c, sorry, this is c and this is a. So c by a. So this is x1 x2 is equal to 2u square cos square alpha upon g into a. x1 4 into 2u square cos square alpha upon g into a. Okay, so this is 16a square is equal to r square minus 8 8a cos square alpha upon g into, let us put the value of u square. So u square is equal to this one. So this is gr upon 2 sin alpha cos alpha. Okay, so this gets cancelled and we have this gets cancelled. So this is 4. So 16a square is equal to r square minus 4r 4r cot alpha into a, 4r cot alpha into a. Okay, so we have the equation of quadratic as quadratic as r square minus 4a cot alpha into r minus 16a square is equal to 0. Okay, so we have r is equal to 4a cot alpha plus minus root under 16a square, sorry, this is x2 minus x1 is 2a. So this is 4a square. Okay, so we have this as 4a square. Okay, so we have minus b plus minus root under b square. So this is 16a square cot square alpha minus 4 into a into c. So minus 4a square. Okay, divided by 2a. So this is equal to 4a cot alpha plus minus root under, this is 16a square. So 16a square common, 1 plus cot square alpha divided by 2. Okay, this is equal to 4a cot alpha plus minus 4a cosec alpha upon 2. Okay, so 2 gets cancelled. This is equal to 2a cot alpha plus minus cosec alpha. Okay, so this is equal to 2a into, let us consider taking positive. So let us take positive sign. So this is cos alpha upon sin alpha plus 1 upon sin alpha. This is equal to 2a 1 plus cos alpha upon sin alpha. This we can write 2a into 2 cos square alpha upon 2 cos alpha by 2 sin alpha by 2. Okay, so this gets cancelled. So this is 2a cot alpha by 2 is equal to range. Okay, so range is equal to 2a cot alpha by 2. Okay, so let us solve question number 8. Okay, so what is given in the question is that two bodies are projected from the same point in directions making an angle alpha and alpha 1 and alpha 2 with the horizontal and strike at the same point in the horizontal plane. Okay, so the range will be same. If T1 and T2 be the time of flight, show that T1 square minus T2 square upon T1 square plus T2 square is equal to sine alpha 1 minus alpha 2 sine alpha 1 plus alpha 2. Okay, so what is given in the question is that two bodies. Okay, so this is first body, movement of first body, this is movement of second body. Okay, so let us consider the initial velocity of the first projectile as u1 and second one as u2. Okay, so the inclination of first projectile is alpha 1 and let us consider the inclination of second projectile as alpha 2. Okay, so range is same for the both the projectile and the initial velocity is u1 and u2. Okay, so what is given in question? Two bodies are projected from same point in the directions making an angle alpha 1 and alpha 2 with the horizontal and strike at same point in the horizontal plane through the point of projection. T1 and T2 with the time of flight. Okay, so time of flight for the first projection, first projectile is T1 and for second one is T2. Okay, so we have time of flight is T is equal to 2u sine alpha upon g. Okay, and range is equal to u square upon g sine 2 alpha. So this is equal to 2u square upon g sine alpha cos alpha. Range is equal to. Okay, so since the range is same, so let us write since range is same for both projectiles, we have R1 is equal to R2 is equal to R. Okay, so let us calculate R1. So we have R1 is equal to 2 U1 square upon G sine alpha 1 cos alpha 1 is equal to, for second projectile, 2 U2 square upon G sine alpha 2 cos alpha 2. Okay, so U1 square upon U2 square is equal to sine alpha 2 cos alpha 2 upon sine alpha 1 cos alpha 1. Okay, so now let us find the time. Okay, so we have T1 and T2 with the time of flight. Okay, the T1 and T2 is not, time is not same. So we have T1 is equal to 2 U1 sine alpha 1 upon G and T2 is equal to 2 U2 sine alpha 2 upon G. So we have T1 upon T2 is equal to U1 upon U2 sine alpha 1 upon sine alpha 2. Okay, so we have T1 square upon T2 square is equal to U1 square upon U2 square sine square alpha 1 upon sine square alpha 2. So let us put U1 square from here, U1 square upon U2 square from here. So T1 square upon T2 square is equal to sine alpha 2 cos alpha 2 upon sine alpha 1 cos alpha 1. Okay, into sine square alpha 1 upon sine square alpha 2. Okay, so this gets cancelled. Sine square alpha 1, this gets cancelled. Okay, so this is equal to T1 square upon T2 square is equal to sine alpha 1 cos alpha 2 upon cos alpha 1 sine alpha 2. Okay, so let us apply componendo and dividendo. The T1 square minus T2 square upon T1 square plus T2 square is equal to sine alpha 1 cos alpha 2 minus cos alpha 1 sine alpha 2 upon sine alpha 1 cos alpha 2 plus cos alpha 1 sine alpha 2 is equal to sine of alpha 1 and alpha 2 upon sine of alpha 1 plus alpha 2. Okay, this is equal to T1 square minus T2 square upon T1 square plus T2 square. Okay, so this is being asked in the question. Okay, so this we have to prove that T1 square minus T2 square upon T1 square plus T2 square is equal to sine alpha 1 minus alpha 2 upon sine alpha 1 plus alpha 2. Okay, let us discuss question number 9. What is given in question number 9? If r be the range of the projectile on a horizontal plane and h be its maximum height for a given angle of projection, so that the maximum horizontal range with same velocity of projection is this one. Same velocity of projection. Okay. So what is given? R is the range of projectile for a horizontal plane. So R we are having is R is equal to 2u square upon g sin alpha cos alpha, and maximum height h is equal to maximum height is equal to u square sin square alpha upon 2g. Okay, and R max is, we have this is equal to u square upon g sin 2 alpha. Okay, so R is maximum when sin 2 alpha is equal to 1. Okay, sin 2 alpha is equal to 1, so we have R max is equal to u square upon g. Okay, so let us take the what we have to show. To show 2h plus r square upon 8h is equal to r max is equal to u square upon g. So let us take the LHS part. The LHS part is 2h plus r square upon 8h. Okay, so let us put the value here. So we have LHS part as this one. So 2h plus r square upon 8h is equal to 2 into h. तो h की वैल्यू क्या है ये? तो 2 into u square sin square alpha upon 2g plus 1 upon 8h. तो 1 upon 8 into 1 upon h. तो 1 upon h is 2g upon sin square alpha into u square. Okay. Into r square. तो r square is square of this. So this is 4u4. Okay. Upon g square sin square alpha cos square alpha. Okay, so sin square alpha gets cancelled, and this is 8. 4 to the 8 and 8 gets cancelled. So we have g gets cancelled. From here, this is u square, and this gets cancelled. So we have u square upon g sin square alpha plus cos square alpha. This is equal to 2h plus r square upon 8h. Okay, so this is equal to u square upon g into 1 is equal to u square upon g is equal to r max. Okay, so we have 2h plus r square upon 8h is equal to, so that the maximum horizontal range with same velocity is, the maximum horizontal range is given by this expression. This is equal to r max. Okay, so what we have done, we have taken the LHS portion and we have placed the value of r and h in this particular expression. So this particular expression is equal to u square upon g, that is the maximum horizontal range. Okay, so let us discuss question number 10. So we have discussed up to question number 9. So let us discuss question number 10. Okay. Okay, so let us discuss question number 10. Okay, so this is the last question on this question series on the projectile motion. Okay, so let's discuss this. So what is given in the question is that if r is the horizontal range and h is the greatest height of the projectile, prove that the initial velocity is given by this particular expression. Okay, so let us consider a projectile with initial velocity as u. Okay, so we have the horizontal range r. R is the horizontal range. So horizontal range is u square upon g sin 2 alpha. This can be further written as r is equal to u square 2 upon g sin alpha cos alpha. Okay, so r square is equal to 4u4 upon g square sin square alpha cos square alpha. Okay, now we have the greatest height. The greatest height h is equal to u square sin square alpha upon 2g. So from here sin square alpha is equal to 2g h upon u square. Okay, so let us put the value here. So this we can further write as r square is equal to 4u4 upon g square sin square alpha 1 minus sin square alpha. Okay, so this is r square is equal to 4u4 upon g square. Sin square alpha is 2gh upon u square into 1 minus 2gh upon u square. Okay, so this is equal to r square is equal to, this gets the 4 into 2 is 8 and g gets cancelled from here, and this is u square. So the 8 u square upon g into h into 1 minus 2gh upon u square. Okay, so this is equal to r square is equal to 8 u square h upon g minus 16. G gets cancelled, u square gets cancelled, 16 h square. So we have r square is equal to r square plus, let us further simplify this. So we have r square plus 16h square is equal to 8 u square upon g. Okay, so let us divide by 16h. So dividing throughout by 16h. So r square upon 16h plus h is equal to 8 u square h upon g into 1 upon 16h. Okay, this is equal to r square upon 16h plus h is equal to, this gets cancelled, this is 2 and this gets cancelled, so u square upon 2g. So this is equal to u square is equal to 2g into r square upon 16h plus h. Okay, so we have u is equal to under root of 2g r square upon 16h plus h. This is the initial velocity is given by this particular expression. Okay, so total 10 questions we have discussed on the topic of the projectile. Okay, thank you.